Yeah, go ahead.
Hi, we're Team2 working on the frame for the second.
Yeah, our subsystem design is the frame one. This is the solid model, and this is the prototype that we did last 2 weeks. Our design contains all all the other subsystem design. Also, it's easy transportation capability. Subsystem to be bolted inside frame, and there are some key variables for our design, which is width, length, height, and weight, the number of wheels, conjunction points, and stress concentration. Also, there are some key statistics for the design that we made it. The width will be like about 18-inch length, 18-inch too, and height 48-inch. The weight will be about 160 pounds. And found that the factor of safety is about 5. Yeah, and it's steel material.
Alrighty, so we went ahead and jumped right into our FEA analysis. We have 2 different analyses, one with the system just sitting on the ground with the simulated weight on shear force on the walls, which would simulate the inside components. For reference, from the 2 components we did have SolidWorks models for, that was both the sifting and as well as the crusher. That was about 116 pounds roughly. So as you can see on the top left, that is the stress while it sits on the ground, and on the right, that is actually the stress while it is being transported. So we simulated the transportation and the stresses on that. I know the factor of safety, you see a lot of red. That is actually a factor of safety of 5. That was the bottom limit that it reached, so it's anything above 5. So we reached all the safety requirements we put in place for that.
Alright, so running the FMEA, sorry, it's a little hard to see here. The severity was basically our main concern was A, security, B, kind of like the actual material, the welds, and just kind of, those are the main key areas here. So in calculating the severity, those were the most severe, the occurrence, they were most likely to occur, and detectability there would be probably the hardest to detect or the easiest. So then the RPM for those was really, really high. And so then, but redesigning, all we have to reconsider for that is, we just got to make sure that it's secured properly, and training for that is really easy. And then also we got to make sure that we have just like the hinges for the doors that will be added later. Everything is just like clean, maintained properly. Just the frame itself just needs to be maintained and properly secure. That was the biggest thing that I'm running this analysis.
So then future considerations are the subsystem installation. For example, like the door was not complete yet, but that's something we'll consider in the future. And the dimension variation, it's easily changeable because the cubicle layout of the design and the full system static analysis for the transportation with the crossbars to see the ideal for that. Then the manufacturing considerations to see like if it can actually be built properly, and training guideline development for the final design for how to actually use it.
That's our presentation. Thank you. Any questions? Yeah.
Did you consider any other forces besides gravity?
Yes, I did. That's what was the shear force. That was actually the simulated weight of both your components as well as the sifting team's components. Sorry?
I'm talking mainly when we're cranking this. The force factor is going to continuously change.
You're absolutely correct. At the time, we did not have any simulation results from the power team. That will be considered for future considerations. That's going to play a big effect, but we just considered weight purely as being the main factor.